We're going to talk now about methods to prepare to make alcohol. So mainly three types of reactions we're going to be studying here. One is the substitution reactions, and that's using alkyl halides, primary, secondary, or tertiary. We go over that, and you probably had to study that already when you saw substitution reactions of alkyl halides in organic chemistry 1. Then we're gonna, another reaction that we're gonna be using is the alkene hydration. So say we start with an alkene like that, doing hydration reactions, which if you guys remember, it is adding HNOH across a double bond, and there's several methods to do that. Lastly, the other type of reaction that we're gonna be studying is the reduction of carbonyl compounds. Carbonyl compounds, we have, like we said, this functional group. And you can have here ketones, and you can have aldehydes or even esters and carboxylic acid. There will be different regions that we're going to be studying for that. So right now, let's go to the first type of reaction, which is the substitution reactions. So referring to the first one here, if you have, say, ethyl chloride. But you can do that reaction, say, with strong base, strong nucleophiles such as OH. And that will be an SN2 type of reaction. So substitution nucleophilic of order 2, and you will get that alcohol. That's it. So that will be the path if you have a primary alcohol. Now, if you have, and remember that designation of primary or secondary refers to the number of, say, alkyl groups attached to your alpha carbon. Here we have 2 hydrogens and only 1 R group, which is a metal. Now let's consider another structure. Say that I have now tributyl chloride. Now that's a tertiary alcohol, alkyl halide. So that's my alpha carbon, and as you can see, we have 1, 2, 3 alkyl groups, which are metal. If you are under another condition, let's draw here, let's do that simply in water. Remember that tertiary alkyls halide will not react via SN2 due to a steric hindrance. SN2 reactions are mostly for primary, and also secondaries can go that way. Definitely tertiaries with a strong base, strong nucleophile do not go SN2. They rather do an E2 reaction. But in this condition, actually, much weaker base and nucleophile, what happens is that you will have a 1,4 step, which is the loss of a leaving group, and you will form a carbocation. That's the SN1 pathway, and in that pathway, after you form the carbocation, you will have, in the second step, the nucleophilic attack, this time by water. And well, your immediate product is not the alcohol. You will get here, say, this is a species that has an extra product, and you will need to deprotonate. So but that's, say, just reviewing substitution reactions again. You can do the SN2 pathway with hydroxide if you have primary or secondary alcohols in the other side of the spectrum, because tertiary do not undergo SN2. You will do that under other conditions, say weak base, weak nucleophiles, such as water. This will dissociate in the first step in the SN2 reaction, producing that carbocation, which will undergo a nucleophilic attack. So that is then how we can make alcohols from alkyl halides.